Fine, guys. So in the previous class, we have seen different types of test, I believe, right? Z-test, T-test, and I have mentioned that next we have two types of test. Okay, one is a chi-square test and one is a ANOVA. Okay, so as mentioned, we will be covering chi-square test in our upcoming class. Okay, so now we are going to see something called as ANOVA. Okay, so now what is ANOVA? ANOVA is a shortcut for analysis of variance. Okay, it's called analysis of variance. Fine, analysis of variance. So what does this mean? We'll try to understand. Okay. Yeah. So see, analysis of variance is a statistical technique that is used to check if the means of two or more groups are significantly different from each other by analyzing comparisons of variance estimates. Okay, ANOVA checks the impact of one or more factors by comparing the means of different samples. Okay, so this is a definition, but fundamentally what does this mean is if you have multiple groups, okay, so this ANOVA will be helpful to find out if the means of all those groups are same or not. Okay, and if at all, if any one particular group is different from other group, if so, and what is that particular group? Okay, see, what we are trying to do over here is, let's say in t-test, in yesterday's class in t-test, what we have done, we have seen is we have seen three types of t-test. Agree? One is one sample. Where was it? Yeah. So if you see here, we have seen one sample t-test, independent two sample t-test, and paired t-test, dependent two sample. So if you see here, independent two sample t-test, so that means what? We are checking, we are comparing the means of two independent samples. Agree? Coming to ANOVA, it is just the extension of that. Instead of two, if you have multiple groups and if you want to check, okay, if you want to check if there are any if all the means of all the variances in that group are same or different from each other, okay, so you can use ANOVA. Okay, but if you have only two samples, okay, t-test and ANOVA give the same results. Okay, getting? So if you have only two samples, okay, sample one, sample two, okay, you can anyhow use a t-test. T-test, what you will use independent samples. Fine. This particular test, independent two sample t-test, where you will compare the means of two independent samples that you can conveniently use and you will get the answer. Here you can also use ANOVA to find out. Okay, but if you have multiple samples, S1, S2, S3, S4, S5, okay, for example, fine. So now t-test cannot be used over here because it will not work for multiple samples. It is either one sample or two samples or paid two samples. That's it. Okay, but if you have multiple samples, okay, and if you want to compare the means of these samples, if they are same or if they are if they're different, if different, how many of them are different, etc. Okay, so you need to use the analysis of variance. Okay, mainly it is to check the two or more groups. Okay, and as I said, if you have only two samples, t-test or ANOVA both will be same. But if you are, however, using a t-test would not be reliable in cases where there are more than two samples, right? So if they have more than two samples, t-test will not be a perfect solution. If you conduct multiple t-tests for comparing more than two samples, it will have a compounded effect on the type 1 error. Okay, what does this mean? We'll see. Okay, and there are few assumptions of ANOVA. The sample should be selected in a random way such that there is no dependence between the samples. Agree? There should be independent samples. That means what? If you're having a population, this is a whole population. Okay, this should be sample 1 and this should be some sample 2. Okay, you cannot take like S1 should not be inside S2 or there should not be any overlapping sort of thing. Okay, so there should be no dependence between samples. Okay, the experimental errors of the data are normally distributed. Okay, so if you are having any errors, okay, that errors should be normally distributed, okay, and assumption of the equality of variance, homoscedasticity, and zero correlation, okay. See, these things are actually related to the linear regression. So when we study the first ML algorithm called as machine learning linear regression, so these are the assumptions of those, okay. I'll be explaining you in detail what does these mean, okay. So you can okay, see what it just means that I'll just give you a brief, but at that time I will tell you in detail what are these assumptions. Okay, so whatever. Hello, 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 hello. Guys, can you hear me?
Yeah, yes, Santosh.
I lost power actually. Okay, sorry. Fine. Okay, so this is regarding the ANOVA. Okay, now we'll see some practical example. Okay, so now if you see in the previous lesson we introduced t-test. Okay, so we introduced t-test for checking whether the means of two groups differ. Okay, two groups, sample one, sample two, means yes or no. You remember my score, Virat score, that example. The t-test works well when dealing with two groups, but sometimes you want to compare more than two groups at same time. Okay, for example, we want to test whether voter age differs based on some categorical variable like race. We have to compare the means of each level or group of variable. We could carry out a separate t-test for each group of pair of groups, but when you conduct many tests, you may increase the chance of false positives. Okay, fine. The analysis of variant ANOVA is statistical inference that leads to same thing what we have discussed. Okay, what he's saying here is, so if you have multiple samples S1, S2, S3, S4, S5, fine. Uh, as I said, t-test will only work for two samples. Okay, only two samples. Now, in this scenario, we can go for the ANOVA. Fine, but if you still want to use t-test only for multiple samples, in that case, what you need to do is you need to consider one pair at a time. That means first you need to consider S1, S2, conduct a t-test, then S2, S3, t-test, S3, S4. So you need to come up with all possible unique combination pairs and then conduct t-test on each one of them and then check the value. But the problem over there is the error gets compounded. That means what if S1, S2 is having some error, let's say E1, and S2 plus S3 is having some error E2. Okay, so error will be added each time and the overall error will be a big error. Okay, because every test might have some error, and if you have like let's say 15 unique combinations, unique pairs from here, the error will be E into 15. Okay, so that's error because you are conducting 15 tests. Each test might have some error, right? So that is a problem which you have conducting t-test on multiple samples. Okay, instead of that, you can use ANOVA. In single shot, you will get the value. Okay, uh, is that clear, guys? Is the definition of ANOVA clear?
Yes, Santosh.
Others, any doubts? Or shall I repeat? Okay. Um, Fine, guys. See, if you're not getting, you can just understand ANOVA is just an analysis of multiple groups means. Okay. So if you have more than two groups and if you want to analyze the means of those, okay, not specifically means, it could be variance, it could be anything. So, but when you want to work on multiple groups at the same time, Okay, then you need to go for the ANOVA. Okay, so we'll see an example. Maybe you will get a better idea. Okay, so see guys, see the one-way ANOVA uh, test whether the mean of some numerical variable differs across the levels of one categorical variable. It essentially answers the question, do any of the group means differ from one another? We won't get into the details of carrying out an ANOVA by hand as it involves more calculations, but the process is similar. Okay, and the Skype has a function ANOVA. Okay, see guys, ANOVA, as I said, see when you're conducting a Z test, okay, when you're conducting a Z test, what was the distribution you have? It was a normal distribution. Agree? Okay, or let me write it here because it will stay forever. Okay, see guys, so when you're conducting a Z test, what was the distribution we worked upon, guys? Normal. T-test, guys, what distribution we worked on for T-test?
T-test, uniform.
Uniform?
I mean, you're asking about example yesterday we have seen or
No.
T-test? Oh, okay. T-distribution. Fine.
Z-test will be applied for normal distribution. T-test will be for the T distribution.
Okay. Sorry, I'm talking about that. Okay.
Okay. And ANOVA, the distribution is called F distribution. Okay. And here it's called as, here what do we call it? Is a Z static. Right? And here we get the value of T static. Right? And here it's called as F static. Okay, the test statistic. Okay, it's not statistic. Okay, so when you're conducting a Z test, it should be on the normal distribution, and the test statistic you calculate is called as Z statistic. Okay, for the T test, it will be on the T distribution, and it is called T statistic. Okay, for the ANOVA, it's called F distribution. It will be, and the test statistic is called as F statistic. Okay, so the same thing is saying over here. So the value which you are going, the distribution will be called as F distribution, and the statistic will be F statistic. Okay, so now we'll see with an example what does ANOVA mean. Like if you have multiple groups and if the mean is differing from each other, so how ANOVA will be able to let us know. Okay, and the how in practically in Python you can use from skypay.stats F1 way. Okay, so you have actually there are two ways of ANOVA, one way ANOVA, two way ANOVA. So first we'll see one way ANOVA. So in one way ANOVA, what does it do? It will just tell us if the groups are different or not. Okay, so one way ANOVA will tell if there are multiple groups. Okay, if there is any one particular group that is different from other or not. It will just tell that. It will not say which group is that. Are you getting, guys? Guys, in one way ANOVA, okay. See guys, in one way ANOVA, okay. So if you have multiple groups, okay. So why ANOVA came into picture? You have group 1, sample 2, sample 3, sample 4, like that. Let's say this is sample 10. Okay, each sample will have its mean, right? X1 bar, X2 bar, like that, X10 bar. Okay, now if you are comparing the means of these, okay, so first of all, ANOVA is useful to work on multiple samples at a time, more than 2. That is first point. In that you have one way ANOVA, two way ANOVA. One way ANOVA will tell if the groups are same or not. I mean, if the all the group means are same or not. Okay, it will just say yes or no, but it will not say which particular group is a culprit or which guy is standing out, who which particular value is creating the difference. It will not go into that details. It will just say if all the values are same or if there is some difference. That's it. Is it clear?
Okay.
Are you guys getting?
Yeah.
Okay, fine. So now we'll see. So these are basic, as you might have observed. So for stats, we are mostly using SciPy, right? So NumPy. So these are the 4 fundamental libraries, okay, tools, I would say, for machine learning. So yeah, so our next focus will be on these 3. So as of now, you might observe from last few classes, we are using SciPy modules, right? So now also, if you see here, what we are doing, we are creating a races. Okay, US same example, the election examples. Okay, there are, let's say there are different types of races, and we are generating some random data. Okay, so such that this is a probability of each race. Okay, Asians will be 0.05%, black will be 0.15%. Okay, the size of 1,000. And there is one more data called as age. Okay, age data we are creating, and then we are creating a data frame. Okay, you are creating a data frame where you have race column and age column, and race column will have this voter race data and age column will have its voter age data. Okay, and then you are grouping by the race column, and once you group it, you will get something. Okay, and once you group it, you can extract these values. Okay, so if I just show you these. Okay. See guys, so once you create this voter race, okay, what it is creating. Okay, so these are the values it is creating. That means what? From these races, this is races, race A equal races. From these races, okay, create total 1,000 values. Okay, such that 0.05% should be Asian. That means how much percent, guys? How many values?
0.05, right?
50.
50 values.
50. Okay, and 0.15 will be 1,000. Sorry, 0.15 percentage of 1,000 should be black. Okay, like the 25 percentage should be Hispanic. Okay, like that you are creating randomly. So that's why you can see there are random values created over here. Okay, this is voter race. Agree? And next you are creating age of these guys. Okay, so what is age? See, age is these values. Okay, with a mean of 18. Okay, and standard deviation of 30. Okay, so what are these values, guys? In the first class, I have told you LOC will be mean, and the MU will be the standard deviation, and the sample size will be 100. Okay, with that you are creating one more value, and when you group them, so you have voter frame is, yeah, so this is what the data frame is looking like. That means you are creating a pd.data frame, means create a data frame. Okay, and where you are having two columns, one is race, one is age. Okay, race and age. In race, what values you want? Voter race values you want, and in age you want voter age. Okay, and next thing is a groups. Okay, in groups you have these values. Okay, grouping by race, that means what? It will first Asian, it will just group, right, black, okay, and Hispanic, other. Okay, so that's how it has created. And once you group them, then you can extract the individual ages. For example, if you see the Asian, okay, so these are the values of Asian or Hispanic, etc., etc. Okay, is this clear, this code part?
Yes.
Yeah.
Okay, so now we have ages for each individual type of race. Okay, a race and its set of ages. Okay, fine. So now how many groups we have, guys? So we have 5 groups: Asian, Black, Hispanic, other, white, right? 5 groups and 5 means you will have. Okay, 5 groups and 5 means you are going to have. Fine. So our goal is to check whether the means, all these means are same or different, if anyone is different. Okay, so that is the purpose of ANOVA. Okay, it will work on multiple groups and it will tell whether the means of these are varying from each other. Okay, so if you see first of all let's try to see the means, guys. So if you see the Asian mean, Black mean, all these means I have printed over here, so you can see they are same. Okay, they will not be exactly same, but yesterday you have seen, right? So if they're close by, that's okay. Okay, so they're like almost close by, it's not like more than one difference. Agree? So that's why when you see, when I'm performing the ANOVA stats dot f one way ANOVA, and for this just see stats dot f one way, from where you are getting. So earlier he has said to carry out the ANOVA one way ANOVA, call skypy dot stats dot f one way. Why f? In ANOVA it will be f distribution. Okay, getting? So in ANOVA it's called f distribution. Okay, that's why f, and why one way? This is one way ANOVA. Okay, so f underscore one way will give you the result. So use f one way, and inside that put all these groups. Okay, put all these groups, and now whatever the p-value you will get, focus on that. Okay, so now what is the p-value? 0.13. Okay, so what will be alpha? P is 0.13, and alpha will be 0.05. Okay, and p is greater than or not? Yes. So if p is greater than, you are going to accept the null hypothesis. Okay, and what does null hypothesis will say? Yes, they are all same. Remember, usually null hypothesis will say there is no difference, everything is same. You say all means are same. Okay, alternate will say no, not same. Okay, so you can see here from the p-value, which is 0.13. Okay, so if we have the diagram over here, so p, if we have 0.05 over here, okay, and 0.13 is greater than 0.05. okay, so in that case the value is more, you need to accept. Is this correct, guys? If the p-value is greater than alpha, should we accept or reject?
Accept.
Right, so the value is more, that means area. P-value is basically area, so you are having more area than alpha, so in that case you need to accept. So when I accept null hypothesis, what does null hypothesis saying? Null hypothesis is saying all are same. Okay, so all are mostly same. Yes, you can see all the, let me show you, all the groups are mostly same. Okay, that we have accepted. Clear? Is the example clear? So like this you can give any set of groups, it will let you know if the groups are same or not. Okay, fine. But now what if they are different? That is important. So in that case, okay, so yeah, so here we got test statistic. See, as I said, f statistic, right? So in the ANOVA it's called f statistic and f distribution, and f values you need to use. ANOVA is f. Okay, and here you have f statistic 1.77, p value 0.3, indicating there is no significant difference between the means. Okay, another way to carry out the ANOVA test is use the stats models library, which allows you to specify model. Okay, which you will use. Okay, see, he's saying there is another way. Okay, from the you have stats model dot API. Okay, and stats model dot formula dot API. So over here you can pass the same data. Okay, OLS data frame dot fit ANOVA dot LM. Okay, actually it looks like this is in the R programming language. Okay, but you can ignore this. It will give the same result. As you can see, f value is what? F value is 1.77, 0.13. Okay, so here also we'll get 1.77, 0.13. Okay, but this is bit different, but you can ignore this. You can just use simple stats.f one way and give all the groups, it will give you the value. Okay, and now let's make new age data where groups do differ. Okay, so if everyone is same, that's fine, but what if they're different? How ANOVA is going to tell us? Okay, so for that, what we are going to do, so for that same thing, so what we are going to, first thing is we have created the ages. Okay, and races are the same races like this, and this is same. Okay, but earlier we have created all with same age. Okay, see, this is just races and these are just ages. Okay, but now that means every age is coming from the same distribution, Poisson distribution, every age is coming from the same distribution. Okay, but now we want to create some difference, so that's why what we are doing, so deliberately we are creating separate age for white. Okay, only for white people we are creating a separate age. Okay, so if you see, the mean is 32. Oh, sorry, the standard deviation is 32 over here, and here it is only 30. Okay, but for all other races it is just this. Okay, but only for white it is this. Okay, so then what we are doing, so you are saying np dot where water is equal to white, that means wherever you have the white. Okay, so it will be white ages. Okay, that will be white, it will take the white ages, it will pick up the age from this distribution, else it will take just the water age. Okay, this single line meaning is that means in these races you are having so many Asian, black, white, Hispanic, like that, right, and others. So this is saying np dot where water is equal to white, that means wherever you have white, take the age distribution from white ages, use this, else if it is not white for any this scenario, go for the normal water age, that is this. Okay, so that's how. And similarly, you are creating the data frame, you are grouping by the races, and you are extracting for each individual race. Okay, so that is done. Now again you are using stats.f1 way. Okay, and you are passing all these individual values. Now if you see, these are the yeah, you are passing all the values and you are performing one way and over. And if you see the p value, right, so if you see the p value, what is this, guys? Is this 4.5?
Exponential, so it will be more less.
Yeah, so it is actually very less than like almost equal to 0. It's like 0.000045. Okay, so you are having a p value which is like 0. Like 0.000045. Okay, 8 zeros actually, and you have a alpha. Okay, usually 0.05. So p value is so much less than alpha. Okay, so you are having a p value less, p value is area, so it is very less, small. Okay, that means moving away from the null. Okay, see guys, I'm repeating this multiple times, this logic, so that it stays with you forever. Okay, so the p is very less, so if the p value is less, so we need to reject the null hypothesis. Okay, and what does null hypothesis again say? Oh sorry, I erased it. Null will say all same. Okay, alternate will say different, all not same. Okay, all not same. Okay, so as you can see, p value is less than alpha, you're going to reject null hypothesis. This guy is saying wrong, so all are not same is correct. Okay, so as you can see, all are not same. So if they print the means again, so clearly you can see the last one. Okay, white dot mean, so it is having 50, which is a bit different from the other. Is that clear, guys? Can you observe that?
Yes.
Okay, everybody, is it clear?
Yes, sir.
Okay, so now you can see that it is saying no, the means are not different, sorry, not same. Okay, so p value, based upon p value, you can clearly reject this guy and observe that some difference is happening inside the groups. Okay, so p value, this is that. Now this is alternate way, you can just ignore. Okay, now to check which group is creating the difference. Okay, so that is also important, right? Here, see guys, here what we have found out here, it is just saying, hey, there is some difference. Okay, that's what it is saying. Okay, so because you have printing these values, you came to know that it is mean, guys. Okay, try to understand. Because we have intentionally created white edges with a different distribution, and you are able to print these values, you already know which one is the different guy, who is the standout guy. Okay, but in real scenario, you will not able to do that. So if you have like hundreds of samples, okay, so you don't know the means of each individual sample, you will just have the groups of values. Okay, and if you pass them to this, it will tell you based on the p value, you can understand. Okay, you can understand that there is some difference, it is happening. Okay, but to know which group is creating the difference, okay, we need to do some workaround. Okay, so for that you have, there are two ways, guys, okay, to find out which group is creating the difference. Okay, one way is as I said, see guys, the test results suggest the groups don't have the same sample means. In this case, since the p-value is significant at the 99 confidence level, we know that it is a white voter who differ because we set it up that way code. Okay, getting? So we know that it is a white voter who is creating the difference because we intentionally set it that way. But when testing real data, you may not know which group caused the test to throw a positive result. Okay, to check which group differs after getting a positive ANOVA result, you can perform a follow-up post hoc test. Okay, one post hoc test is to perform a separate t-test. You can perform t-test all pairs and you can find out that. Okay, so here he's saying that because we have set it up that way, you know it is white over, but in real life you may not be able to know which group is causing. To know which group is creating the difference, you need to perform something called as post hoc test. Okay, so one way of post hoc test is t-test. You can utilize t-test to find out. And second thing is you have something called as QK test. Okay, so we are going to see that so that you will understand. Okay, so initially we'll see t-test. Okay, so how you can perform t-test to find out which group is having difference. Same thing, you need to find out all unique pair combinations and then run t-test independent. Okay, you remember stats.t-test independent. What is that? Where are we getting it from? It is from this test, guys, independent two sample t-test. Okay, so that is the thing he's saying, to conduct t-test on each individual group. Okay, so first you need to find out the all different types of groups. Okay, you have, these are the different combinations: Asian, Black, Asian, Hispanic, Asian, other. Okay, these are the different types of combinations. Okay, and once you pass, okay, once you run t-test through each of these pair. Okay, so you say, so what you're doing, so race 1 is in range of 4 and race 2 in range of race 1 plus race 4. This is a code. Okay, and what you're doing, so these are the race pairs. Okay, race pairs dot from where he's picking up, append races of race 1, races of race 2. Okay, so okay, got it. So you are having races. What are races? These are the races. You need to take the all unique pairs. Okay, simple. What we are going to do first, if you take this as the 1 and this will be the race plus 1. Okay, that means Asian plus Black, Asian plus Hispanic, Asian plus other, Asian plus white. Okay, for race in range 4, okay, and race 2 in range race 1 plus 1 comma 5. Okay, so you are appending this. Okay, this is a small for loop. Okay, I think you can understand this because we have discussed the for loops. Okay, so the main concept here is you need to create groups like this way. Okay, the race pairs, you are creating race pairs. How you're doing? See, Asian Black, Asian Hispanic, Asian other, Asian white, and then Black Hispanic, Black other, Black white. Okay, and Hispanic other, Hispanic white, and other white. Okay, so all unique combinations we can create from this particular code. Okay, so after that, what you are doing, so you are taking pair at a time. That means race 1, race 2, and race pair, and you are passing the stats.t-test independent two sample independent t-test, and you are passing what? Voter age groups of race 1 and voter age group of race 2. Okay, each pair you are running through each of these pair, and you are running a t-test on those. Okay. Is the code part clear, guys? Let me know. Or any doubts in this?
No, Santosh. Fine.
Okay, fine. So simple, guys. You are creating different pairs. Okay, you are creating pairs and then passing each pair to that and performing t-test. That's it. Okay. So once you pass that, see guys over here. So these are the results. If you observe for Asian and test, this is a result. Okay. For Asian and Hispanic, this is the result. Okay. Like that for other and white, this is a result. Okay. So now if you try to observe, okay. So let's try to just see wherever the value is less than 0.05. Okay. Agree? Because why? If it is value, if p value is greater than 0.05, okay. So that means you need to accept the null hypothesis. Okay. Null hypothesis. And what the null hypothesis is saying? Both are same. That means we are considering only two samples at a time now. T-test, right? T-test, independent two sample t-test means you consider only two samples at a time. That means null hypothesis will say both are same. Do you agree? Alternate will say both are different. Fine. So now we
Yes.
want to find out that pair where alternate is winning. That means both are different. Then you will find out which particular group is causing the difference. If P is greater than 0.05, then null is winning. That means both are same. Okay, that's fine because if two samples are same, okay, I know most of the samples are same, but I want to find out that guy who is causing the difference. That means wherever the p-value is less than 0.05, where the alternate hypothesis will win, which will mean that there is some difference between those two groups. Is that clear? Is the logic clear what we are trying to do over here?
Yes. So last two only. Here we can see only last two.
No,
Those are less than.
not really. Because here if you see this is 0.05. Okay, this is 0.05. This is okay, great. But here, see, that's what you don't do. You don't do
Okay,
the
yeah,
mistake.
E.
It is E.
Yes, yes. E,
Okay.
yeah.
See here, this is also extremely 0.05. Okay, so this is okay. Okay, this is 0.05, just 0.05. Okay.
0.051. So I thought it's
Okay.
greater than
Okay, this is okay. But here if you see 0.02,
0.50, yeah.
okay, and 0.03, okay, and 0.6, okay, 0.4, okay. Okay, so if you see there are four places, okay, 1, 2, 3, 4 places where the given two groups are different. Agree? Now if you see what are those groups over here, if you see this is Asian and white, okay, over here it is black and white, over here it is Hispanic and white, over here it is other and white. Clear? Every time you can see the common white guy which is causing the difference. Every time for this guy only the p-value is getting less than 0.05 here, 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 which means white is very much different from the other values. Is it clear?
Yeah, Santosh.
Meghna?
Yes. Clear.
Clear, right?
Yes, sir.
Yeah. So because we are not doing anything fancy here, just we are taking two groups at a time, check the p-value and let me know if the value is less than 0.05 so that I can reject the null hypothesis, which means they are not same. Okay, I just want to know that which is having the difference. That means I want to see which guy is creating the difference. That for that I definitely need p-value should be 0.05. This thing you should understand. Why 0.05? Because then only I can reject the null hypothesis. I want to reject null hypothesis and accept alternate. Why I want to accept alternate? Alternate is saying there is some difference and I want to find out the difference, guy. Okay, so that's why here and somewhere here, here there is a difference, and clearly you can see the white guy is causing the difference. Okay, so this is one way using independent t-test. Okay, you can find out, you can create independent, you can create different t-test, okay, and find out. So but here problem here is if you have like 20 groups, guys, okay, the combinations will increase, right? What if you have like 100 groups? There you will have so many combinations. Okay, so many t-tests you need to perform, so much effort, computational power, memory, right? So in other ways, you have something called as I said, QK test. Okay, so yeah, so it's a conversion approach to okay, you can carry out 2K test using pairwise 2K function to get the same value. Okay, so over here it is very simple. So instead of this is one way I've shown you t-test, okay, pairing. Okay, otherwise you can directly do what you have something called as from stats model.stats.multi-comp import pairwise 2K HSD. Okay, this is some test they have invented. Over here you need to just pass the voter age, voter race, and your significance level. Okay, and once you plot this value, see, it will only create multiple combinations. Okay, group 1, group 2 combinations, and it will say what how much it is differing. Okay, it's whether it is lower side, upper side. Okay, and it will say whether I want to reject. That means whether it is creating difference or not. Okay, mostly if you see here, reject is true. Here it is true. Here it is true. And if you see what is the common guy over here, here also it is white. Here also it is white. Here also it is white. Okay, mostly. So from this also directly you can understand that white guy is the culprit guy. This guy is creating the difference. Okay, so over here you can do only one single test instead of multiple tests like in t-test. Okay, you can just go with the 2K test and pass the groups. Okay, just pass the groups whatever you want to for data, it's groups, significance level, that's it. Okay, so directly you can find out which group is creating the maximum rejects. Okay, you don't know to do this group, it will directly give you this table. Okay, so from this also it is clear that white is having the difference. Okay, and also why, because if you see the mean of all the groups are somewhat less than this, but the white is greater than 50, right? So for example, if you see what was a white yeah, it is 50 point something one, everything is less than 48, 47 something, right? Agree. So that's why you can, if you see the graph also, you 50 point something one will be over here, the mean of white. Okay, sorry, mean of white will be 50 point something. Okay, but for other it is around 47 point something and 47 or 48, 48. Okay, but mean of this is over here. Okay, so from this also you can understand that white, this is white guys, see this is white. Okay, these are for other groups. Okay, from here also the white guy is creating the difference. Getting?
Yes, Santosh.
Okay, so the output of the two gated shows the average difference in confidence interval as well as whether you should reject the null hypothesis of pairing. Okay, in this case, the test suggests we should reject the hypothesis for 3 pairs white with each pair including white category. Okay, so which suggests that the white group is likely different. Okay, so the 95% confidence interval plots the results. Okay, only one other group confidence interval overlaps the white group confidence interval. Okay, so only this guy is having some overlap, but still his mean is falling to this side only. Okay, but however, you can see the white guy is likely mostly different from the other groups. Okay, so this is how you can perform ANOVA, right guys? Okay, so basically we have seen two things. Okay, just to summarize, right? So first thing is analysis of variance is for different groups. Okay, so if you have different groups, it will be helpful. So as you can see, we have worked on different set of groups, like 5 groups. Okay, and it's called T distribution, so F distribution, and the statistic is F statistic. Okay, and one way ANOVA is where it will just tell you whether the groups are same or not. Okay, it will just say yes or no. Okay, that is one way ANOVA. And the logic is same, p-value same thing, same conclusion, checking p-value, everything you will be same. Okay, and next you have something called as two-way ANOVA. In two-way ANOVA, what we have seen, sorry, okay, in two-way ANOVA, you can also find out which particular group is causing the, okay, which particular group is causing the difference. Okay, in this also we have seen two tests. One is t-test. Okay, that means paired two tests. Okay, but the problem here is you need to have so many tests you need to perform. Otherwise you have something called as QK test. Okay, it is very simple, one line. You can just pass all the groups, how many groups you want, you can just pass it to this guy. Okay, and give the alpha significance value. He will give you the beautiful table. From this you can see which particular group is having the maximum rejects. You will have one common guy, and that guy is a standing out guy. With this you can also find out which group is making the difference. Okay, once you're having the difference, then what you might think what we need to do. What we can do if that guy is having the difference, now consider that guy, focus on that guy and find out, and then use all your again statistical techniques. Okay, see the distribution of that guy, see if he's having any outliers, why his mean is different. Okay, and try to remove that outliers. Okay, apply some box plot. Okay, and again do some transformations. Okay, and we will see what all we can do. Okay, but first of all, it will help us to at least find out which guy is different. Okay, how to handle we'll see later. Okay, is it clear, guys? Are we good?
Yes.
Okay,
Yes, sir.
fine, cool. So that's regarding the ANOVA. So yeah, so as I said, we have only one test that is pending. Okay, called chi-square test. Okay, so it will require around like 40 to 45 minutes. Okay, we'll mostly let's try to meet up in today evening. Okay, sometime. Okay, we'll discuss and we'll try to wrap this up. Okay, and post from tomorrow we can clearly start numpy. Okay, that's the plan. Okay, cool, guys. That's all from my end. Thank you so much.
It's not just one doubt.
Yeah.
That LOC and standard deviation, right? So we have taken 18 and 30,
Mhm.
18 and 32. I mean,
Mhm.
I have small confusion. Can you please, what exactly it is? That location parameter.
Yeah, this is a okay, for Poisson distribution. Okay, for Poisson distribution, this will be the mean. Okay, so fine, that's a good question. Let me just okay. So 1 second, guys. Is the recording done or what?
No, it's recording.
Okay, wait.